Welcome to Cosmic Compass, the channel where we explore the wonders of space and uncover the mysteries of the universe. Together, we travel beyond Earth to see the planets, moons, and cosmic phenomena that shape our solar system and beyond. In today's journey, we'll look for the most promising places where life might exist within the inner solar system. From the fiery surface of Mercury to the icy poles of Mars, let's discover which worlds might still hold the secrets of life beyond our own planet. Life is one of the greatest mysteries of the universe. Out of billions of stars and countless planets as far as we know, today, Earth is the only place where life exists. It is a world full of oceans, forests, and atmosphere uniquely balanced for life to thrive. Why is that a combination of very specific factors makes Earth so special? Our planet sits in the so-called Goldilocks Zone, not too hot, not too cold, just the right distance from the sun to allow liquid water to flow. Earth also has a magnetic field shielding us from the harmful radiation of the sun and the cosmos. Our atmosphere is rich in oxygen, something we can breathe, and water covers more than 70% of the surface. When you add all these pieces together, Earth becomes a safe haven for life as we know it. Yet when we look around the solar system, no other world appears even remotely like this blue and green marble we call home. So let's ask the question, does that mean life exists nowhere else in the solar system? The simple answer is we don't know. But there are places that still hold potential, and scientists are very eager to investigate them. Today, let's journey together through the inner solar system from the Sun past Mercury, Venus, and finally Mars to see where the best chances of finding life might be hiding. Our journey begins with the heart of the solar system, the Sun. It is a stable middle-aged star, scientifically called a G-type main sequence star. Without it, Earth would not exist, and life here would never have developed. Yet, ironically, the Sun itself is not a place where life could survive, at least not in any way we understand it. Surface temperatures reach thousands of degrees. Any known molecule of life would be instantly destroyed, and yet some scientists, including the famous astrophysicist Neil deGrasse Tyson, have speculated about the possibility of life made of pure energy, alien beings existing as plasma or fields rather than atoms. Could such things exist? Perhaps mass is energy, energy is mass. It is not impossible to imagine, but the probability is so remote that for now we can safely say if life exists in our solar system, the Sun is not where we should expect to find it. Let's continue outward. The first planet from the Sun is Mercury. At first glance, it may not seem like a likely place for life, and indeed it is not. Mercury has only the thinnest veil of an atmosphere far too weak to hold in heat or protect against radiation. This leads to some of the most extreme temperature swings in the entire solar system. On the day side, under the blazing sun, temperatures soar above 400 degrees Celsius, but once the planet rotates into darkness, they plummet to 170 degrees. Imagine such a world, scorching heat by day, deep freeze by night. Scientists have discovered deposits of water ice in permanently shadowed craters at Mercury's poles. That sounds promising, doesn't it? But here's the catch, the ice never melts. It is locked away frozen solid, and life, as far as we understand, it requires liquid water to function. Mercury was geologically active billions of years ago with volcanic eruptions shaping its surface, but today it is a silent, inactive world, harsh, sterile, and almost certainly lifeless. Let's move on. Next comes Venus, often called Earth's sister planet. At first the resemblance is striking. Venus is nearly the same size as Earth, with a thick atmosphere and even clouds. But this is where the similarities end. Venus sits just a little closer to the Sun, outside the comfortable Goldilocks zone. Its atmosphere, instead of being life-friendly, is a suffocating blanket of carbon dioxide making up 96% of the air. The result, a runaway greenhouse effect. Temperatures on the surface climb above 460 degrees Celsius hotter than Mercury, even though Venus is farther from the Sun. To make matters worse, the pressure at the surface is over 90 times greater than Earth's equivalent to being nearly a kilometre underwater. In such conditions, water cannot exist as a liquid. Any droplets would boil away instantly. From the ground, Venus appears as a true inferno. And yet higher in the atmosphere, far above the surface, things change. Temperatures and pressures there are far more moderate. Could microorganisms exist in Venus's clouds? It is an idea that has intrigued scientists for decades. In fact, in 2020, researchers reported signs of phosphine gas, a possible indicator of life within Venus's atmosphere. The claim remains debated, but it reminded us that Venus may not be as dead as it seems. Still, if life exists here, it would not be on the surface, but drifting far above, hidden in the hazy clouds. Finally, we reach Mars, the fourth planet from the Sun, and the most studied world besides our own. Mars is a fascinating case. It lies on the outer edge of the Goldilocks Zone, where liquid water could, in theory, exist. It even has an atmosphere. But unlike Earth, Mars lost its protective magnetic field billions of years ago. Without it, the solar wind stripped away much of its atmosphere, leaving behind a thin shell composed mostly of carbon dioxide. This thin air cannot hold onto heat. Today, Mars is a cold, dry desert, and yet all across its surface are signs of a different past: dry riverbeds, valleys, carved by flowing water, and minerals that could only have formed in liquid. Once long ago, Mars was warm, wet, and potentially habitable. If life ever arose, there could it have survived? Scientists have searched for decades. The Viking missions in the 1970s looked for biological activity. More recently, orbiters and rovers have scanned the Martian surface for traces of methane, a gas that on Earth is often produced by living organisms. Some detections have been made, though their origin remains uncertain, perhaps geology, perhaps biology. Another clue comes from Martian meteorites found on Earth. Some of these rocks contain microscopic structures resembling fossilized bacteria. Are they evidence of ancient Martian microbes? The debate continues. Natural processes could also explain them, so where should we look for life today? One possibility lies underground. Just 10 meters below the surface, liquid water could remain stable, shielded from radiation. Another possibility is beneath the polar ice caps, where seasonal patterns hint at hidden activity. Strange spider formations, dark streaks that appear when carbon dioxide sublimates in spring, could just maybe be linked to microbial life. This is why Mars remains at the center of exploration. NASA's Perseverance rover is searching directly for signs of ancient microbes in Martian rocks. Other missions from Europe, China, and beyond are preparing to bring samples back to Earth. Will we find life on Mars? No one knows. But within the next few decades, we might finally get a clear answer. So far, we have journeyed past the Sun, Mercury, Venus, and Mars, 4 very different worlds each with its own story to tell. The Sun provides energy, but no shelter for life. Mercury is too extreme, with no stable environment. Venus is Earth's dark twin, an inferno below, but with a faint chance in the clouds. And Mars, dry and cold, still teases us with hints of what might have been and what might still be. Why does this matter? Because finding life elsewhere in our solar system, even just microbes, would be revolutionary. It would mean that life is not unique to Earth, but a natural outcome when the right conditions exist. Imagine what that would imply for the billions of planets around other stars. This is why scientists focus so much on the Goldilocks Zone, on habitability, and on biosignatures like methane or phosphine. Each discovery, each rover landing, each orbital scan brings us one step closer to answering the question, are we alone? And while we often talk about facts, it's equally important to understand how we know them. Through physics, chemistry, and problem solving, we can uncover truths hidden across millions of kilometers of space. That is the essence of exploration, not just to observe but to understand. So here we are. We have visited the inner solar system searching for life among our closest neighbours. Earth may still be the only confirmed world with life, but Venus and Mars remain compelling candidates. Next time, let's venture further outward toward the gas giants and their icy moons, where oceans might lie beneath frozen crusts. The story of life in the solar system is far from over. If you enjoyed this journey, consider liking and sharing the video. It helps us continue exploring together. And of course, subscribe to Cosmic Compass so you don't miss the next chapter. Until then, keep looking up and keep wondering, because the universe is full of mysteries waiting to be discovered. Thank you for joining us on this journey through the inner solar system. Earth may still be the only confirmed home of life, but the possibilities on Venus and Mars remind us how much there is left to learn. If you enjoyed this exploration, don't forget to like, share and subscribe to Cosmic Compass. Your support helps us bring more stories of the cosmos to life. Until our next adventure among the stars, keep asking questions, keep exploring, and remember, the universe is always waiting to be discovered.